Hey people. I hope you had a good break. I am sick, so I'm not there. Hopefully I'll be back this week though. But anyway, we have a new topics to start. So this is topic 3, and this is going to be all about functions. Okay. Functions are going to be just a special way of saying equation. But they're very, very special types of equations, so they have some rules that go with them, okay? So today is going to be all about identifying what is a function and what is not a function based on the numbers that we could put into our problems and get out of our problems, okay? So, let's jump into it. All right, a function, I'm at the top here, I'm going to read this definition. A function is a relationship, and by relationship, I mean equation, shown with a set of ordered pairs. Okay, ordered pairs. Think back to the last unit that we had. When I say an ordered pair, I mean an x value and a y value. Okay, so every time we look at one of these functions, they're going to give us an x and a y. All right. Okay, let me continue with this. Shown with a set of ordered pairs where each, I'm going to write in there, input has exactly one output. So if you put something into your equation, you should only be able to get one thing out, okay? So if I have 2 plus 2, the only number I should ever get out of that is 4, or else it wouldn't make any sense, right? And that's the idea here, is we're trying to put numbers into equations and get a certain number out. But it can only be one answer that we get out. It can't be 2. So think of functions as machines. One thing goes in and one thing comes out, right? Imagine ingredients going into a blender. Okay, thinking about blenders. Blenders only blend, right? Blenders just do one job. That blender is going to be our equation, okay? So if I put a number in, or let's say I put bananas in to my blender, right? The blender is going to do its job. It's going to, swirl everything up until we get out a smoothie. And that is going to be a banana flavored smoothie, right? Because you put in banana, so it should be banana flavored. That makes sense. Okay. So what if we put in a new fruit or a new number into our function? I'm going to put strawberries into my function or my blender. The blender is going to do its job. It's going to mix everything up, right? And out will come a strawberry flavored smoothie. Makes sense because we put strawberries in there, so we should just get a strawberry flavor. All right, okay. If I put in strawberries into my blender, it does its job. Does it make sense that I would get out a banana flavored smoothie? No, because I didn't put any bananas in it, right? So why would I get a banana flavored anything if I didn't use bananas, right? This is the idea. If you put in a number into your problem, you should be only able to get one other number out. It's not going to make sense if you get 2 different numbers, right? Like I said before, if I add 2 plus 2, I should only get 4. I should never get anything else except for 4. And that's the idea here. If we ever come across a situation where we have the same thing being put into our problem, it should only ever give you one thing out. It should only ever give you a strawberry flavored drink if you only put in strawberries, right? Okay. So, using that analogy, our functions are like blenders. They only have one job. They only do one thing. If you put in a number, you should get out a different number. You shouldn't get out, 2 different things, because that wouldn't make any sense. So let's move on down here where we have our 3 ways to look at a function. We have tables, which look like this. We have mapping, which looks like this. And we have graphs that look like this. Okay? Those are 3 different ways, and there's one more in here as well, but I'll talk about that in a second. All right. To identify a function from a table or mapping, the inputs cannot repeat ever. Like I said before with our strawberries up here, we can't have 2 different things coming out of our blender if we only put in strawberries. Okay? So, that's the idea. If we ever have a repeating input, whatever we put in is repeated, then it's not a function. All right? So let's try that out on this first question right here. Let's try it out on number 1. Here are my inputs. Here are my outputs. Here we're talking about fruits and their different colors. All right. Strawberries will give us a red color. Sure, that makes sense. Strawberries are red. Okay. Bananas will give out yellow. Right, okay, bananas are yellow. They can also be other colors, but for right now, they're yellow. Grapes can be purple. For sure. Makes sense. I've seen those at the grocery store. Strawberries give orange. I don't know about that one. I don't know that I've ever seen an orange colored strawberry before. Not sure that one makes a lot of sense. Okay. So, again, we put in the same input. We should get out the same color, right? It's the same item. We should get the same thing out, but this is giving us 2 different things. So, since that does not make sense, and again, it's set up here, the inputs cannot repeat. Here I have 2 repeating inputs. This is not a function because these 2 things, strawberries, pop up more than once. They repeat. Therefore, this is not a function. Okay? Again, the same thing cannot pop up more than once in your inputs because every input has to have 1 output. If we put in strawberries more than once, it should just be red every time. Okay, all right. Well, let's use that same idea for the mapping problem. This is number 2. This is a map. So we still have our ins and our outs. Okay. So let's read this. If we put in apples, they should be red. Okay, sure. Yeah, it makes sense. Red apples do exist. All right. Grapes are going to match to purple. Okay, yeah, because grapes can be purple. Strawberries are red. Sure, all right. And bananas will match to yellow. Yeah, okay, cool. That all makes sense, right? Okay. None of our inputs are repeating. We only have apples, grapes, strawberries, and bananas. All of those fruits are different from each other. So, yes, this is a function since there are no repeats. Okay. So, you might have noticed that both the apples and the strawberries are both red. That is fine. Having repeats on the outputs is okay. It's just on the inputs that it doesn't make sense, right? Both apples and strawberries can both be red at the same time. That's okay. The problem comes is if we have 2 things that give you 2 of the same thing that give you different outputs, then we're not good. This is okay though. Both the apples and the strawberries can be red at the same time. All right, okay. So let's go back up to the top here. And let's finish reading what it says. We got one more blank to fill in. It says to identify a function from a graph. Okay, so that's going to be this guy right here. Use the, I'm going to zoom in here, vertical line test. Okay, we're going to do this like Blue's Clues, all right? Show me with your hands which way vertical is. All right, good job. So we knew that it was going to be up and down, okay? So the vertical line test is a test that we're going to apply just to graphs, all right? So I'm looking at this graph. I have a circle on my graph. To conduct the vertical line test, you are going to draw a vertical line anywhere on your shape. So I'm just going to put it right here. That's where I'm deciding to put my line. Okay. Now I'm going to count how many times this circle crosses this vertical line. Okay. So I'm going to see it crosses once here and then again down here. So that is 2 times. To pass the vertical line test, you can only cross 1 time. Since this crosses 2 times, this is not a function. Okay, because it crosses here and here. I'm going to write that over here. Crosses more than once. So it is not a function because it crossed more than 1 time. Okay, so you're just applying that test to whatever shape is drawn on here. For us, it's going to be this circle. Okay, since that circle crossed that vertical line more than 1 time, it is not a function. And that, again, that vertical line could be put anywhere you want. I could have put it over here or over here or over here, and it wouldn't matter because no matter where I'd put it, it would still hit more than 1 time. So that's the idea. Okay, cool. All right. Well, we know that if we see a table or a map, we're going to have to just look at those inputs and see if any of them repeat. Okay. If we see a graph, we have to do the vertical line test. But I'm looking at this and I see that number 7 and number 8 look a little bit different than the rest of these problems. So let's take a look at number 7. Okay. So we have 2, 1, 3, 9, 2, 5, 8, 6. Okay, well that doesn't look like a table. That doesn't look like the mapping either, and it definitely doesn't look like a graph. They look like coordinates to me. So just like at the top of our notes here, we had something that looked like that, right? We had ordered pairs. Ordered pairs meaning you had an X and a Y value. So our X's are going to be our inputs and our Y's will be our outputs. So I'm going to label all of my X values first. So let's see. My X's are going to come first in the set. So I know 2, 3, 2, and 8. These will all be my inputs. Okay, so if it helps you out, you could definitely write it. Put my ins. We said that was 2, 3, 2, and 8. That's a little squished up. Let me move that out of the way. In. We said 2, 3, 2, and 8. There we go. Okay. So, looking at my inputs, do we have any repeats here? I'm seeing that we have a 2 and a 2. Those are repeating. And looking at those pairs, they also have different Y values. So those are going to be our outputs, all right? So X's equal ins, Y's equal outs. So my inputs do repeat. So again, if they do repeat, that means that it is not a function. And I'm going to, again, kind of like highlight this a little bit so I know what I mean for later for my notes. These 2's repeat. So they are not a function because our 2's repeat, okay? All right, so I'm going to have y'all finish the rest of these. I know it's not much, but I mean, it's the first day back. And this is going to be a fairly quick unit. Actually, it's only going to take us about 2 weeks to get through. So we're going to start off slow. All right. You have the rest of these problems to figure out if they are functions or not. Okay. I believe in you, and I hope you have a good rest of your day, and I'll see y'all later. Bye.